Swayam Prabha. Digital India. Educated India.
Welcome back. So, in the last lecture we just discussed about the stress path for CD test, isotropically CD test, and there we have seen the stress path is making an angle 45 degree with the horizontal, and we have established one new kind of failure envelope, that is nothing but the modified failure envelope, and that is known as KF line, and we have established the relation for the inclination between the inclination of KF line and the original failure envelope like this. Now, we are considering a new kind of test, right. Normally consolidated clay we are considering, and we are considering it is subjected to isotropical CU test, and then we would like to find out the stress path for this kind of test. Now, at the beginning of the application of deviatory stress, your sigma 1 prime is equal to sigma 3 prime is equal to sigma 3, because you are again considering the consolidated test. So, that consolidation is happening in the stage 1, and that consolidation is happening due to the cell pressure application, that is sigma 3. So, at that time you are considering the drainage, right, otherwise consolidation will not be happening. So, you are considering the drainage, therefore, sigma 1 prime, that is the effective major principal stress, is equal to effective minor principal stress sigma 3 prime is equal to the total stress sigma 3, right, because you are considering the complete consolidation. Now, hence P prime is equal to sigma 3 prime, right, and Q prime is equal to 0 for this kind of situation. Okay. So, this is represented by point I. So, the same point. So, in case of consolidated drain test and in case of consolidated undrained test, this point is lying on your P prime axis, because that is known as isotropically consolidated test, right. So, all round you are applying the sigma 3 and then you are consolidating the sample. So, this I point will be represented by this state of stress. Okay. Now, basically now you are shearing it, right. Now, you are applying the deviatory stress. So, that means you are applying the axial deviatory stress, and therefore, you are increasing the total stress in the sample, and eventually or effectively the total stress will be coming to the effective stress. There will be two Mohr cycles, one is total stress Mohr cycle, another one is effective stress Mohr cycle for CU test, because now you are considering undrained situation when you are shearing the soil sample, right. So, now you have started the test from this point I. Okay. Now, you are progressing, now you are applying the deviatory stress. Now, how the stress path will move? Let us see. Now, at some other stage of the deviatory stress application, that sigma 1 prime is equal to sigma 3 plus delta sigma d minus the pore water pressure developed during the deviatory stress application at any stage. I am not talking about the failure, that means you have started shearing and till the failure, in between at any stage you consider, this is the effective major principal stress, that is sigma 1 prime, that is equal to sigma 3 plus delta sigma d. What is sigma 3 plus delta sigma d? That is nothing but sigma 1 minus the pore water pressure delta ud will give you the sigma 1 prime. Similarly, what will be the value of sigma 3 prime? That is nothing but sigma 3, that is the all round cell pressure minus the pore water pressure sigma delta ud, right. So, that will give you the sigma 3 prime, that is effective minor principal stress. So, that means this point will be talking about sigma 3 and this point will be talking about sigma 3 prime. So, the difference between these two is delta ud. So, this is nothing but your delta ud. Okay. Similarly, sigma 1 prime and sigma 1. So, this is your sigma 1, this is your sigma 1 and this is your sigma 1 prime. So, this difference is also delta ud. So, the center of the Mohr circle will be also having the difference of delta ud. So, this is nothing but the center. Okay. The difference between the center of the total stress motorcycle and the effective stress motorcycle will be also delta UD. Okay. So, that is coming from your CU test. So, if you recall your CU test concept. Okay. Now, in this situation, in that stage, whatever value of sigma 1 prime and sigma 3 prime have been obtained. So, based on that I can calculate P prime, which is nothing but sigma 1 prime plus sigma 3 prime by 2, which is nothing but sigma 3 plus delta sigma d by 2 minus delta UD, right. So, if you put these values, you will be getting sigma 3 plus delta sigma d by 2 minus delta UD. So, that is your P prime. Okay. Now, what is the value of Q prime? Q prime is your sigma 3 prime minus, this will be, I am sorry, this will be sigma 1 prime. Okay. So, sigma 1 prime minus sigma 3 prime by 2 is equal to delta sigma d by 2. Okay. So, you have got Q prime and P prime. Now, you are going to plot this thing in the P prime Q prime plot or the space. Now, which point will be denoted by this? This point, right. If you see, if you look at, so P prime is equal to sigma 3 plus delta sigma d by, so sigma 3 is here plus delta sigma d by 2. So, you will be getting the center of the total stress motorcycle minus delta UD will be giving you the P prime. Am I right? Similarly, Q prime is your delta sigma d by 2, that is nothing but the radius of the motorcycle. Now, here you can see that when we are talking about P prime and Q prime, basically that is associated with the effective stress motorcycle. So, we have got a point U prime. So, this is the point which is nothing but U prime, right. So, similarly at any stage you draw the motorcycle like this, okay, and you try to establish the topmost point on the motorcycle, you will be getting another point, say U prime, and so on, and ultimately the conditions 5.38 and 5.39 will plot U prime. So, points such as U double prime represent values of P prime Q prime as the test progresses. So, as I told you, so initially you have got U prime, then as the test progresses you will be getting another point, say U double prime, and another point U triple prime, and so on till the failure, right. So, at failure, so your P prime is nothing but sigma 3 plus delta sigma d by 2, delta sigma d f by 2 minus delta UD f. What is delta UD f? That is the pore water pressure at failure, and what is delta sigma d f? That is the gravimetric stress at failure. So, this is your P prime and this is your Q prime, which is defined by the point U. Okay. So, if you draw the motorcycle, you will get it. So, you draw the motorcycle for total stress and effective stress, you will be getting the point U, which is on the failure envelope OF prime. So, the conditions 5.40 and 5.41 will plot point U. Okay. Hence, the effective stress path for a CU test can be given by the curve I U prime U double prime U. Okay. So, I U prime U double prime U. So, this curved path is your stress path for the CU test, agreed. So, how it is moving? So, it is not the straight line now, it is rather the curved line. You can get it, I mean for any say test, CU test or CD test, if you plot the stress path, you will be getting, one will be your straight line, that is CD test, you will be giving you the straight stress path, whereas the CU test will give you the curved stress path. So, basically what I am getting? I am getting, say this is Q prime, this is P prime. So, I am starting from the isotropically consolidated test, that is point I. Now, if I perform CD test on the sample, I will be getting the stress path like that, which is making an angle 45 degree. If I use, or if I apply CU test or if I perform CU test on the same sample, I will be getting a curve like that. Then that will be meeting the failure envelope. Okay. Is that clear? So, I will be getting the failure envelope, I mean by getting these two paths. Now the situation, now the condition is that basically you have started with the same condition. This is your condition, initial condition before starting or before beginning of the test. Now you have moved through the separate path when you are talking about the CU test and when you are talking about the CD test. Now by seeing this trace path, immediately you can identify that what type of test has been performed and how the test has progressed. So this is a trace of the test, right. So if I say this is my trace path, right. So I can understand, so the test is happened in CU test. So this is your CU test and CU test is happened along this path. Okay. Similarly, if I have the CD test has happened along this path. I hope that you have understood this trace path, because this concept is very fundamental and very important concept for understanding the critical state soil mechanics. However, by knowing this, you can plot for any test. It is not only CU test or CD test, any kind of test. Suppose you are considering say CU test. Okay. So suppose for example, I mean you are doing first, you have applied all round say cell pressure. Now first you have performed CU test. Okay. Before going to the failure, you have opened the valve and you have done the CD test for the same sample. So that means partly CU and then partly CD. Okay. This kind of situation may happen in the field, right. So initially the consolidation has happened, but initially there is no drainage, and immediately after the application of stress some amount of drainage is happening. So CU test combined with CD test, so that kind of thing also you can perform by this. So what will happen in that situation? It may, so this is your isotropically consolidation, this is your Q prime P prime space. Okay. So initially you have started CU test, okay, and then you have done CD test. Okay. So this kind of, so by seeing the stress path, basically you will be understanding that how the test has progressed, how the test you have performed, right. So I will stop here today. In the next lecture we will be talking about another type of shear test, that is vane shear test, and then we will be discussing about the Skempton pore water pressure parameter, and that will conclude the chapter shear strength. Thank you very much.